Hello, let's continue our Sudoku adventure with Cookie Jar by Stuart Sharpe. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these peach lines in the grid that have a stripe in them to help you identify them, in case some people can't distinguish colors. Anyway, these peach lines are entropic lines. So the way these work is any consecutive, any digits, any 3 digits along the line, any 3 consecutive digits along the line, like these 3, these 3, these 3, these 3, they need to have one of each from low, medium, and high digits. So that's 1, 2, 3, 4, 5, 6. So we could do, say, 2, 3, 6, or we could do 2, 4, 6, or 2, 4, 5. Or if this one wasn't there, we could do 1, 4, 5. We can also swap the order around. We could do like 5, 4, 1. We could do 4, 5, 1. What matters is what we have one of each. What we can't do is 1, 2, 4 because we don't have one of each now. We're missing the high digit. But keep in mind that that's also true of these 3, these 3. It's all the overlapping ones. All right. And then modular lines, these teal ones, work very, very similarly, except the groups are different. The groups are based on the remainder after dividing by 3. So our groups are 1, 4, 2, 5, and 3, 6. And again, order doesn't matter. What matters is that we have one of each. So basically, the 3 digits have a distinct value, mod 3. All right. And then finally, these two sum to 5. That's it. V is the Roman numeral for 5. All right, that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Well, we might as well just write 1, 2, 3, 4 here, since these have to sum to 5. And we're almost done. Let's see. So coloring is going to be a little complicated because the coloring on a entropic line is going to be different than the coloring on a modular line. But I do want to color this line to see how these two relate to each other. So what do my colors mean, I guess, is something I should explain. So these 3, you'll notice we have one of each group. That's just part of the rules. So I'm calling this the green group, the purple group, and the orange group. Now, we don't know which is which, but we know they represent the 3 distinct groups, the low, medium, and high. But now these 3 also need one of each, but they already have a purple and an orange, so they needed a green to go with it. And so we end up cycling because now these 3 have an orange and a green. They need a purple. So we go green, purple, orange, green, purple, orange, green, purple. So we have a green and a purple spanning our sum to 5. And we know that that does not involve any high digits because you can't use 5 or 6 to sum to 5. And so orange is our high digit. These are a 5, 6 pair. And these are all 1, 2, 3, 4, I guess. It's not a 1. So we know 1's in one of these two. Now, we already have all our oranges here. So that means the rest of this row is green, purple only. Oh, and we don't have any oranges here, so these are both orange. So these are a 5, 6 pair. And the 6 tells us the order. That's 5, that's 6. Now, all we know is that these aren't high, but we already knew that. So I think with what I don't know, with what I've penciled, do I want to... The question I'm having is whether I want to get rid of the colors at this point. It is still useful to know that these are the same group. These are the same group. We know this isn't purple and this isn't green because the purples and greens are gone from the columns. That's all we know there. So this group, let's just pick 3 new colors. So let's do red, yellow, blue, red, yellow, blue, red, yellow. So let's think about how these groups relate. We have 1 and 4, so that's going to be a low and a medium. We have 2 and 5, that's going to be a low and a high. And we have 3 and 6, which is going to be a medium and a high. So we represent each combination of low, medium, high, medium, high within each color. So this can't be green. Oh, no, it could be. It could be the same digit as this. Oh, okay, yeah. We know that these 2 reds are different, though, so it can't be green, but we already knew that. See, it's not a 5 or a 6, but that just tells us that it's not the high of the medium or high. Or sorry, of the 2 and the 0 mod. Anyway, I don't know what I'm saying. This is green or purple. Oh, this is orange, I suppose. So what did we learn about this? Is there anything interesting about this line? Okay, so well, maybe it has to do with these two, one being red, one being yellow. So we know they add to 5. So, oh, and they aren't the same color. They aren't the same color for modularity. So because they aren't the same color for modularity, we can't do 1 plus 4. So we have to do 2 plus 3. So that's a 2-3 pair. It doesn't actually tell us low-high. So this is the 1-4 green, because it sees a 2-3 green. And this sees a 2-3 purple, and it can't be 1, so it has to be 4. And that tells us that purple is our medium. So that's 3, and that's 2. These are both 1s, and now I don't need my oranges. I don't need my green, purple, or oranges anymore. Okay, so that's not a 1. There we go. Okay, perfect. So now we know that these are the 3-6. So this is 6. This is a 3-6. These two are the we know these are the 2-5. So this is 5 and this is a 2-5. And then we know that this is the 1-4 pair. And so we know that's 4 and that's 1. I hope I did this right. I'm gonna have to trust myself. I'm getting rid of the colors now. So there must be Sudoku to do. Yeah, these 4s look in. This is a 4. This is the other 2-5. 2-5 pair. This is 1-3-6. That's not a 1. So this is the only place for 1 in the box. Yep. We have the 2-5s looking up. So 5's one of these two. Anything else to do here? This is a pair. This is a 2-3 pair. This is 2-3-4. We know the 4 can only go here. This is 2-3. This is a 3-6 for the column. 2, 3, 5, 6. We know this isn't 6. Well, I guess we already knew that. In fact, this is just a 2-3 pair as well. So what's the point of these guys? I'm not sure. This is a 5. This is a 1-2-3. Yeah, so the 1 goes here. This is a 2-3. This is a 4. 2-3-5. 6 in this box can only go here now. So that's 5. 2-3-6. 6 is one of these two. That's okay. 2-3-5. Oh, it's not a 3. It's 2-5. So okay. So we probably have to finish it with this. Yeah, these can't be a 5-6. That might be important because of the entropic line here. 2-3 would be okay, and we could use one of the 5-6s as that would be okay as well. So it's just not 5-6. I think that's what's going to have to finish the puzzle for us. I don't see any other way to finish. Oh, these are not entropic lines. These are modular lines, so they do something. We can't do 3-6. This has to be 2, and that's 3. Okay, maybe that's all we needed. 2-3, 2-3. That's 5, 2. That's 6, 2, 6, 5, 3. That's 3, and we're done. All right. I don't know that I use this line then. Anyway, doesn't matter. Sometimes there's extraneous lines to make certain solve paths easier, because this is not intended to be a series for super advanced crazy people. Anyway, just bite-sized puzzles. Cool. Nice puzzle, Stuart. Hopefully I did that analysis correctly. I mean, I got the correct answer. I'm always a little paranoid that I got lucky in some way, but hopefully I didn't this time. Hope you enjoyed this. If you did, then why not leave a like, subscribe, and a kind comment below.